We can use imaginary numbers to factor sums of squares. So here we have x squared plus 9. Remember that x squared plus 1 can be factored as x plus I multiplied by x minus I. Similarly, x squared plus 9 can be factored as x plus 3i multiplied by x minus 3i. To check that this makes sense, you can make a little expansion box. And expand this product. This is x squared, 3ix, negative 3ix, and then we have 3i multiplied by negative 3i, which is negative 9i squared, and negative 9i squared is negative 9 multiplied by negative 1, which is just 9. And now we can apply this pattern to factor other sums of squares. So for example, x squared plus 16 factors as x plus 4i multiplied by x minus 4i. 4x squared plus 144, well first let's factor out 4. That'll give us x squared plus 36. Then we get 4 multiplied by x plus 6i multiplied by x minus 6i. Here we have another sum of squares, 25x squared plus 49. This factors as 5x plus 7i multiplied by 5x minus 7i. Even if we have a number that is not a perfect square, we can use the square root of that number to do this factorization. So 7 has a square root of just root 7, so we can factor x squared plus 7 as x plus I root 7 multiplied by x minus I root 7. And it's standard to keep the I in front of the radical. Similarly here, x squared plus 11 factors as x plus I root 11 multiplied by x minus I root 11. Now we're going to do a problem that helps us review a technique called factoring by grouping. So we notice that the first two terms of this cubic both have factors of x squared. So we can factor out x squared from x cubed and from negative 2x squared, and that gives us x minus 2. And then we notice that both of these terms have a factor of 16. So we can factor out 16, and we get 16 multiplied by x minus 2. So we can use the distributive property in reverse, and we can group x squared plus 16 together multiplied by x minus 2. And then we can use what we know about factoring sums of squares. This is x plus 4i multiplied by x minus 4i multiplied by x minus 2. So let's use this technique again here. Both of these terms have a factor of x squared, so we factor x squared out. We get x minus 1. Both of these terms have a factor of 64, so we factor out 64. We get 64 multiplied by x minus 1. We group x squared and 64 together, which gives us x squared plus 64 multiplied by x minus 1. Again, this is like the distributive property in reverse. And then we factor x squared plus 64 as x plus 8i multiplied by x minus 8i, and then we have that multiplied by x minus 1.